Welcome to Spaceverse, your portal to cosmic adventures. Imagine a planet so extreme, so alien that one side boils with molten metal while the other smolders in eternal darkness. A world so deformed by its parent star's gravity, it's stretched into the shape of a football and teeters on the brink of being ripped apart. Welcome to WASP 121b, a place unlike any other in the known universe. Discovered nearly 900 light-years from Earth, WASP 121b is a hot Jupiter, a massive gas giant that whips around its star in an incredibly tight 30-hour orbit. That's right, just over a day for an entire year on this hellish world. But what makes this exoplanet so fascinating isn't just how close it is to its star, or how unbelievably hot it gets. It's what it reveals about the violent and chaotic lives of planets far beyond our solar system. And now, thanks to NASA's James Webb Space Telescope, we're closer than ever to understanding its wild, turbulent past. And trust us, this planet has a story to tell. Let's start with the basics. WASP 121b orbits a star that's hotter and brighter than our Sun. It's so close that powerful tidal forces, the same kind that pull on our oceans during full moons, have warped it into a stretched, egg-like shape. These tidal forces aren't just pulling, they're ripping at the planet. If WASP 121b moved even slightly closer, it could be torn apart entirely, spaghettified by gravity. Because it's tidally locked, just like our moon is with Earth, one side of WASP 121b always faces its star. That means the day side, the side in constant sunlight, reaches temperatures of over 3,000 degrees Celsius or 5,400 degrees Fahrenheit. That's hot enough to vaporize metals. In fact, scientists believe it may rain liquid iron on this blazing hemisphere. The night side, forever turned away from its star, is no haven either. At a simmering 1,500 degrees Celsius or 2,700 degrees Fahrenheit, it's still hot enough to melt lead. This is one of the most inhospitable places ever discovered. But as hostile as it is, WASP 121b is a gold mine for scientists. And now the James Webb Space Telescope has unlocked secrets buried in its atmosphere, secrets that point to a cosmic migration, a tale written in vapor and starlight. The James Webb Space Telescope, or JWST, is the most powerful space observatory humanity has ever built. Using its near-infrared spectrograph, or NIRSpec, astronomers can study the light passing through a planet's atmosphere as it transits its star. That light carries chemical fingerprints, clues to what the planet is made of, how it formed, and even where it might have come from. Leading this mission was Thomas Evan Soma, an astronomer from the University of Newcastle in Australia. His team's goal to decode the exotic chemistry of WASP 121b's atmosphere. And what they found was astonishing. They detected carbon monoxide, water vapor, methane, and for the first time ever in an exoplanet atmosphere, silicon monoxide. That last one raised some eyebrows. Silicon monoxide isn't something you just casually find floating in a planet's skies. According to Evan Soma and his team, this molecule likely came from planetesimals, essentially asteroid-sized building blocks from the early days of planet formation. These chunks of rock and metal may have collided with WASP 121b when it was still a baby planet, delivering silicon trapped in minerals like quartz. As the planet spiraled inward and heated up, those minerals vaporized, turning into atmospheric silicon monoxide. It's like finding archaeological ruins in the air. But here's where things get really interesting. WASP 121b wasn't always living on the edge of destruction. Astronomers now believe it formed farther out in its star system, somewhere cooler and calmer, perhaps in a region similar to where Jupiter or Uranus orbit in our own solar system. Out there, it had access to icy particles rich in oxygen and methane, giving it a balanced chemical recipe. But over time, the planet began to migrate inward, likely pulled by interactions with other massive objects in its system. As it moved closer to its star, the supply of icy, oxygen-rich pebbles was cut off. But the carbon-rich gases kept flowing. That created a chemical imbalance, one that's still visible today. The result? An atmosphere with more carbon than oxygen, a scar left by its chaotic journey inward. According to planetary scientist Joanna Barstow from the Open University in the UK, these chemical fingerprints help us understand not just this one world, but the behavior of all gas giants in extreme environments. It's a cosmic mystery written in atoms and answered with infrared light. Meanwhile, another group of scientists, led by Cyril Gap at the Max Planck Institute for Astronomy in Germany, took things a step further. They built detailed three-dimensional models of WASP 121b's atmosphere. Why? Because this isn't a simple planet with evenly distributed heat. The day and night sides are wildly different. So are the winds, the clouds, the chemical reactions. Their models allowed them to separate data from different parts of the planet, like taking a planetary weather report from thousands of light years away. One major discovery, methane gas detected on the night side of the planet. And that was surprising. At the temperatures on WASP 121b's night side, methane should break down. It's just too hot for it to survive. So where is it coming from? According to Anjali Pete, an astronomer at the University of Birmingham, the methane must be getting refilled, likely from deeper, cooler layers of the atmosphere below. That means there's strong vertical mixing, updrafts and downdrafts, moving materials around in ways we didn't expect. As Thomas Evans Soma puts it, this poses a challenge to current exoplanet models. Scientists will now have to adjust their simulations to account for the extreme and turbulent behavior of planets like WASP 121b. So why does all of this matter? Why spend time studying a scorching ball of gas halfway across the galaxy? Because WASP 121b is a window into planetary evolution. It helps us understand how planets form, how they move through their systems, and how they change over time, even under the most hostile conditions imaginable. Every molecule detected, every anomaly spotted, adds to our understanding of what's possible in the universe and what kinds of worlds might be out there. The discoveries from JWST don't just paint a picture of one exotic planet. They help us rewrite the story of planetary systems, including our own. As the James Webb Space Telescope continues to scan the skies, more exoplanets like WASP 121b will be put under the microscope. Each one will have its own secrets, its own scars, its own story. And with each discovery, we move closer to answering the ultimate questions. How unique is Earth? What kinds of worlds are out there? And could any of them ever be home? Thanks for joining us on this journey into one of the galaxy's most extreme planets. If you enjoyed this deep dive into WASP 121b, give us a like, hit that subscribe button, and stay tuned for more wonders from the James Webb Space Telescope. Until next time, keep looking up. You're watching Spaceverse, where the universe comes to life. Don't forget to subscribe for more cosmic discoveries, epic space science, and mind-bending journeys across the stars. Until then, stay curious, stay cosmic,